Okay, so in this lesson we are going to go through chapter 10, two sample tests of hypothesis. So we talked about hypothesis testing in detail on chapter 9. So the process, those 5 steps that I've talked about in that chapter remains the same for this one as well. So I'm not going into too much details of the 5 steps. Instead of that, I will talk about what's the difference between chapter 9 to chapter 10. So chapter 9, just to give you a quick refresh on chapter 9. In chapter 9, we talked about validating a hypothetical statement about population mean, or validating a hypothetical statement about population proportion using a hypothesis test. That's what we did in chapter 9. So we had situations where we have a claim. So a manager claims their monthly bill, average monthly bill is more than $200. Okay, so we don't know whether this is actually true or not. This is just their claim or their concern, right? So what we did is we gathered a sample, and then using that sample we try to validate whether this is an actual thing to worry about. Do they need to do something about it, or can they just disregard this concern, right? So what we did is we identified the parameters. So we are talking about, according to this one, we are talking about the average mu, and we build the comparison more than, and then the hypothesized value, right? So this one is called hypothesized. So we compared our parameter population mean to a hypothesized value. Parameter is more than hypothesized value 200. And is it true? Is it not? That's what we've tried to figure it out using the hypothesis test. And to give you an example on proportion, claim could be proportion of percentage of smokers. In city A is higher than, or let's say it's not 35%. Okay, so this is a claim. Somebody claims that in their city the proportion of smokers is not 35%. Let's say that they do have this statement, they do have this general statement that the proportion of smokers in that city is 35%. That's just by default, they know that. But then somebody comes in and then they say, okay, it is not 35%. I don't believe that it's 35%. So now we have a hypothesis to test, right? So according to this one, our parameter is proportion, and the comparison is, it is not, and this is the hypothesized value. Okay, so when you build it, proportion is not 35%. So that's what we want to test using a hypothesis test. So in both cases, we were comparing a parameter to a hypothesized value. In chapter 10, what we will be doing is we will be comparing, rather than comparing a parameter to a hypothetical number, a numerical value, we will be comparing two populations, two groups, men versus women, right? So the average exam score of male students versus female students, average amount spent on shopping of females are more than average amount spent on shopping by males. So we are comparing two populations. So basically we are comparing two parameters. So we would have that sort of a hypothesis to test. So then we use two sample test of hypothesis. So for example, so let's list some examples. So in chapter 10, examples of hypotheses. So let's say the average earnings of a degree holder is less than the average earnings of a master degree holder. Let's say somebody claims that the average earnings of a degree holder is less than the average earnings of a master degree holder, right? So now we have two populations. So we have all degree holders in one group, and then all master degree holders in the other group. So we are basically comparing two populations, or else you can say we are comparing two population means. So if I take mu D to be the average earnings of a degree holder. So for the population, we don't know what that value is. And then for the entire population of master's degree holders, let's take it as mu M. So this is average earnings of a master's degree holder. Okay, so this claim up here, this claim is about these two values. So the claim is actually telling us mu D is less than mu M. See, again you have a comparison, but this time you're not comparing a parameter to a number, you're comparing a parameter to another parameter. You're comparing two population means, but the idea goes same way. So when you want to, let's say that you want to test this, whether it's true or false. So if you want to test this using hypothesis test, your step 1 should be building H0 and H1, right? So you look into this comparison, and then you can see less than sign, right? So less than sign means this is your null. So sorry, this is your alternative, my bad, right? So that's your alternative, indicates your null hypothesis should be mu D greater than or equals to mu M. So you're testing one versus the other. So here's your step 1 of the hypothesis testing. And then what we do is, now we take two samples instead of one sample, like in chapter 9. Now you have to take two samples. So one sample out of the population of all degree holders, the other sample should be from the population of all master's degree holders. So you will have the same amount of information. You will have a sample mean for degree holders, sample size for degree holders, standard deviation for degree holders, and then you will have sample mean for master's degree holders, sample or population standard deviation for master's degree holders, and then the sample size for master's degree holders. So you will have two summaries, right? So using the two summaries, you're going to calculate the test statistic. And then you will have the significance level, alpha, and then you will calculate the p-value using MegaStat, and then you will do the exact same comparison, p-value to alpha, to make the conclusion. So the only difference comes into step 1. So that is where the major change from chapter 9 to chapter 10. Rather than comparing a parameter to a number, we are comparing a parameter to another parameter. Population mean compared to another population mean. Population proportion will be compared to another population proportion. So let's take a look at one more example. Okay, so let's say a cigarette company claims that the rate of smokers, let's say rate of male smokers is higher than the rate of female smokers. Okay, so that's their claim. So their claim involves the entire population. So we have two populations, all male smokers, and the other one is we are comparing to all female smokers. So what they're saying is, well, actually it's not just about the smokers. It's like all male population versus all female population. All males and all females. So then what we are trying to figure out is, out of this male population, what portion are smokers, right? Because we can divide them into smokers and non-smokers. So that total, so number of smokers, number of male smokers divided by the total number of males, that's the proportion of male smokers. So let's take that to be P of M is the proportion of male smokers. And then over here, again we can do the same thing. Again we have non-female smokers versus female smokers. So if I know the total females, I can calculate P of F, proportion of female smokers. Okay, so the cigarette company claims that proportion of male smokers is more than proportion of female smokers. That's what they say. And if we know the numbers, if we know how many males live on this planet, how many females live on this planet, and if we know how many of them are smokers, then we can directly check this. But unfortunately we can, right? It's too much to do, so we can really test this. So that's why we are going to run a hypothesis test, gather samples from both, take a sample, study the samples, and then run the test, say whether this is actually a true claim or whether this is an invalid claim, invalid statement. Okay, so this is, again, this looks like an alternative, greater than sign. So then we are testing this versus the null should be less than or equals to proportion of female smokers. So that's the step 1 for reduced sample proportion test. Okay, right, so that's the major difference between what we did in chapter 9 to what we will be doing in chapter 10. And when it comes to the average, so comparing to population means, we do have 2 cases. So comparing to population means, we do have 2 cases. So one is comparing to independent groups, and the other one is called comparing to dependent groups, so we call it paired observations or comparing to dependent groups. So the idea here, the difference between these two, is that when you run the test, we use 2 different approaches within MegaStat. So what your goal is, you read the question and you figure out, okay, am I comparing to independent groups? So the male smoker, a smoker being male versus a smoker being female. So are those 2 groups dependent or independent? Does one has something to do with the other? So if that's the case, you go with dependent case. If the 2 groups doesn't seem to be depending on one another, so a male's choice of being a smoker has nothing to do with a female being smoker, right? It's their individual choice. So that example I gave you goes under independent category. And if I give you some examples on dependent category, it's like if you want to make a comparison, like you have a current state and then you introduce something new there, and then you want to see what would be the result of that introduction. So before and after comparison is often goes under dependent category, paired observations, before and after comparison. Let's say that a certain program, so let's say that we have several students enrolled in a certain program, and then we've introduced some new workshops for them, APA workshops and some other workshops for them, and then we want to know whether those workshops has improved the knowledge of those students. So it's the same group of students who will be compared before and after, right? So same population compared in 2 different stages. Before the program, before the workshops, what is their level of knowledge? And after the workshop, what is their level of knowledge? So that's a dependent paired observation situation, right? So males, comparing males versus females in a situation, goes under independent category. So comparing product A versus product B, independent groups, right? So you have to make sure you understand, and you have to make sure that you correctly figure out whether I'm dealing with independent groups, two independent groups, or whether I'm dealing with two dependent groups, right? So that's all you need to know in order to perform a hypothesis test for two samples. And then let me add some practice into this. Okay, so worksheet, question number 1. A poll of 400 people from village 1 showed 250 preferred chocolate raspberry coffee to the regular blend, while 170 out of 350 in village 2 preferred the same flavor. So we are comparing a flavor preference between village 1 to village 2. To test the hypothesis that there is no difference, so pay attention to keywords, there is no difference in the two villages, what should be the alternative hypothesis? So when you think about this case, chapter 10, worksheet, question 1. So we have all people in village 1 versus we are comparing all people in village 2, right? So we are interested in what parameter. Is it the mean we are comparing, two population means, or are we comparing two population proportions? That is extremely important. Identifying that correctly is extremely important. So when you think about this question, if you want to figure out the flavor preference, you have to count, right? So out of everybody in village 1, how many would prefer this flavor? That's how you would think about this, right? Out of everybody in village 2, I'm going to count how many would like the flavor, this particular flavor, right? And that's one way to figure it out. So it's a proportion. If you're counting something out of many, out of the total, that's usually a proportion. Also, by looking at the information given to you. So obviously, this is the sample proportion for village 1, 250 divided by 400. And this is the sample proportion for village 2. So you have two sample proportions given to you. So definitely this is a question about proportion. So what we are looking at is this. P1 is the proportion of people prefer the flavor in village 1, and P2 is proportion of people in village 2 who prefer the flavor. So we are comparing these two population proportions. So what's the comparison? So we have P1 on one side, we have P2 on the other side. How does the comparison go? So it says to test the hypothesis that there is no difference. No difference. That means they are the same. No difference. This is what it is. So this is what they want to test, right? And now classify it. So you need to classify. Is this an alternative? Is this a null? So always if you have the equal sign, it's a null. So this is H note. So the question has given you H note, but it's actually asking you to figure out H1. What is the alternative, right? So once you know this is H note, you can easily figure out H1. It's the complete opposite. There you go. So this is the answer. P1 not equals to P2. Actually, they have rearranged it a little bit. So answer is D. So I will show you how it's done here. So what they have done is they put this P2 into the other side of the equation. So this becomes P1 minus P2 not equals to 0, like simple algebra, right? So that's your alternative, and that's the answer to question number 1. Okay, and then let's see number 2. A national manufacturer of ball bearing is experimenting with 2 different processes. Okay, that indicates we are going to compare 2 different processes, process A versus process B, for producing precision ball bearings. It is important that the diameter be as close as possible to an industry standard. So they have to maintain the industry standard, right? Otherwise they wouldn't fit, right? If you don't control the quality of their product, it is going to be problematic. So the output from each process is sampled. The average error from the industry standard is calculated. So they have used 2 different processes to manufacture ball bearing, and then for each process they are going to compare the average error, right? What's the average error of process A versus what's the average error of process B. So we have the sample information, mean, standard deviation, and sample size. The researchers interested in determining whether there is evidence that the 2 processes yield different average errors. So that's what they want to know. So in this question we have all output from process A versus all output from process B. Okay, so we want and then they are measuring, what they are measuring is the average error. So mu of A is the average error in process A, and mu B is the average error in process B, right? So what the comparison is, what they want to test is whether they are any different. Are they not the same, right? So go back again, read the last one. The researchers interested in determining whether there is evidence that the 2 processes yield different average error. So that's what they want to test. So by looking at it, you can see definitely this is your alternative, right? So then you can build the corresponding null to be mu A same as mu B, right? So like I mentioned in chapter 9, you can write it down in words. So average error of process A is not same as average error in process B, right? You don't need to use notations if you're not comfortable with it. You can write it down as a statement. Okay, and here average error in process A is same as average error in process B. Okay, so that's step 1. And then step 2, test statistic. Okay, I'm going to use Excel for that. Step 3, the alpha. Let's see if it's given. Yeah, 0.01. And then step 4, p-value. We are going to depend on MegaStat. Step 5 is to make the conclusion. Okay, right. So now we are clear that this is about the average. So in MegaStat, when you go to MegaStat, first, like we did in chapter 9, now we need to summarize. So instead of 1 summary, we have 2 summaries now. Okay, So summary of process A and summary of process B. Add labels. Make sure you add labels. It's important. And what are the numbers? So 0.002, 0.0001, mean, standard deviation, and then the sample size 12, and then this one is 14, 0.0026, and then 0.00012. Okay, so in that exact order, mean, and then standard deviation, and then sample size. Here also mean, standard deviation, sample size. Okay, so now when you go to MegaStat, hypothesis testing, so now you need to figure out between these two. Remember I said two cases for mean, comparing two independent groups versus paired observations, comparing two dependent groups. So we are comparing process A versus process B. Process A making a mistake, making an error in their production has nothing to do with process B, right? They are two independent processes. So we have to go to compare two independent groups. And then I have the summary input. So I'm going to go with the summary input and then click on group 1. Go back to your groups, select first process summary, including the label. And then click on group 2, select the second summary. Okay, and then don't change this one. This one, hypothesized difference is usually 0. And the alternative, let's go back and have a look at the hypothesis. So your alternative is this, not equals, right? So add the right alternative, not equal from here. By default, it's not equal. And then here, T versus Z. So first one is T. And disregard the second one, unequals variance 1. So we are not going to cover that in this course. So it's between the T test, the first one, and the Z test. So you know the choice. It's starting from chapter 8. We have been through this, right? So when it comes to population mean, we have to look at the standard deviation. So if you read the question once more, it says, the output from each process is sampled and the average error from the industry standard is calculated. So the results are presented below. So these numbers, standard deviations, 0.0001 and 0.00012, they are from the sample. So they are both sample standard deviations. So hence T. Okay, so don't worry about these, just leave them blank, click OK. Okay, so like we had before, it's going to generate the test statistic and the p-value. To test statistic is a negative minus 13 point, so that is a t-value, negative 13.706. And then look at the p-value. What is that? P-value looks strange. 7.61 e to the power minus 13. What does that mean? So e to the power minus 13 means 10 to the power minus 13. So this is actually 7.61 times 10 to the power minus 13. So if I expand this, it's like 0.1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 7, 6, 1. So this is what the p-value is. Very, very, very small number, right? Very, very small decimal. So you can assume it's 0. So if you happen to have e to the power minus something, you can always assume it's 0. So your p-value is 0. And we are comparing, what is this? And we are comparing, oh, I lost it. Okay, come back here. Okay, right. So if you're comparing p-value to alpha, so p-value is 0, alpha is 0.01. So 0 is less than 0.01. So we reject H note. So if we go back, what is our H note? We reject, we say no to this. That means we say yes to this. Right? So that means we are saying yes, the average errors are not the same. We don't know which one is higher, which one is lower. Only thing we can conclude from this test is that they are not the same. So based on the information, average errors are not the same. So that's all we can tell. Right. And then so all these questions, same approach. So this one is for proportion. So question number 5, I'm going to do number 5, and then I'm going to jump to a textbook question to show you an example for paired observations. So this one, question number 5. To compare the effect of weather on sales of soft drinks, a soda manufacturer sampled 2 regions of the country with the following result. Is there a difference in sales between the 2 regions? So we are comparing region A versus region B. So they want to figure out, does the weather impact on the sales? So they have a sample of 100 and the sales were only 1000. Out of 1000 drinks, only 400 was sold in region A, and in region B, out of 1500 bottles, only 500 were sold. So by looking at this information, you can easily tell whether the parameter is mean or proportion, right? So we are counting how many were sold out of the total. So we are comparing proportion of sales in region A to proportion of sales in region B. Proportion of sales in A, proportion of sales in B, right? And then what is their claim? Is there a difference in sales? So same idea like we had before. So we are testing, are they the same or are they different? Versus PA not equals to PB, step 1. Okay, step 2, test statistic. Step 3, alpha, I didn't see alpha is given. So assume, it's not given. Assume 0.05. And step 4, p-value, don't know yet. 5, the conclusion. So this is a test for proportion. So we're comparing 2 population proportions. So it's only one test we have, the second last. Compare 2 independent proportions. Go in and you have group 1, group 2. So you have to provide the sample proportions. So for region A, 400 out of 1000. So 400 out of 1000. And for region B, it's 500 out of 1500. Don't change the difference, it's always 0. And alternative, going back, check in. Alternative not equals, right? Not equals. Click OK. Here you go. Test statistic 3.4, p-value 0.0007. So 3.4, 0.0007. So 0.0007 is less than alpha 0.05. Reject H node. So the answer is yes, there is a difference in sales. Okay, right. And then the last one, like I said, to give you an idea about paired observations, I will use a question from the textbook. So let me pick one. So this textbook has so many nice questions. If you want to try some of it, go for it. So page number 336, look at this table. An investigation of the effectiveness of an antibacterial soap in reducing operating room contamination resulted in the following table. The new soap was tested in a sample of 8 operating rooms in the Cambridge area during last year. So they want to know effectiveness. It doesn't say what we are recording here. So we will assume that effectiveness in a scale, right? 6.6 on a scale of I don't know, 0 to 15 or something. So what they have done is, in each operating room, so these are the same operating rooms, A to H. So each operating room, they have tested the effectiveness before the soap and then after using the soap, right? So they want to measure whether it has been effective or not, right? So the effectiveness rate has whether it has gone up or gone down, no change. So that's what they want to test. So basically this one doesn't seem to give us a right hypothesis, right? It doesn't say exactly less, more, or not equals, but you can think in the sense that make the only thing that makes sense is that they want to know whether this new soap has increased the effectiveness of effectiveness in this reduction of contamination, right? So we can pick the hypothesis in this case. So if you think about that, so step 1, you need to build your hypothesis, right? So let's take average rate before, average rate after. So rate of effectiveness, average rate of effectiveness before the use of soap and then average rate of effectiveness after the use of new soap. So if you want to know whether this new soap have improved the effectiveness, so we are going to do is mu after average rate of effectiveness. Is it higher than that before, right? So that is your alternative H1. So your null should be the opposite, mu FA after less than or equals to mu of before. So that's your step 1. And obviously we are comparing the same room. Room A will be compared before and after, room B will be compared before and after, C will be compared before and after, so and so. So it's the same room before and after. So this is a dependent situation. So if you're always doing a comparison between a same thing before and after conditions, it is always a paired observation question. Okay, so now the numbers are in a different format. So far we've had always summaries. In this question we don't have summary, we have the data, so we have to type that data. So first thing I'm going to type the data set. Okay, so before and after. So 6.6, 6.5, 9, 10.3, 11.2, 8.1, 6.3, 11.6. After 6.8, 2.4, 7.4, 8.5, 8.1, 6.1, 3.4, and 2. Okay, so instead of summaries, we have data. So in this question, we had summary, sample mean. Well, of course, you can calculate the sample mean before, right? Sample mean after. You can calculate the standard deviation before, standard deviation after. But you don't have to because we have the data input option. So now you go into paired observations and then in data input. So let me go back and check once more the hypothesis. So the hypothesis goes this way. Mean after is greater than mean before. So we have to select the after data set into group 1. So group 1 is after data set. After, and group 2 is before. Okay, and then hypothesis difference 0. And the alternative is greater than. So the reason I did after, the reason I selected the after data set is because this is how the comparison goes. Group 1 is greater than group 2. That's what this tells us, right? So that means after is greater than before. So that's what we have up here in the alternative, right? H1 says after is greater than before. So that's why it's important. You first select the after and then select the before. Okay. And between T and Z, we've used sample. Of course, it's sample standard deviation that we are going to have, right? So use t-test and click OK. Right. So these are the numbers. 3.024 minus, and then 3. Let's see if we have alpha. No. If not, take 0.05, and then p-value is 0.9904. P-value 9904. Okay, the comparison 0.9904 is greater than alpha. We do not reject H naught. So that means going up here, we do not reject H naught. So yes to this, no to that. Okay, so we do not reject H naught means we accept it. That means, in other words, we reject the alternative. So by saying we reject alternative means the effectiveness has not gone up after introducing the new soap, right? It is still lower or the same, right? So you have to, this part is very important. Interpretation is very important. So you need to make sure to rewrite this statement in actual words, right? But this means the new soap did not improve the effectiveness of reducing contamination. There you go. Okay, so I have discussed 3 cases. For mean, you have 2 sides, comparing to independent groups and comparing to dependent groups, paired observations, and then proportion. So we have basically discussed this one, compared to independent groups, and then paired observations, and then compare to independent proportions. So altogether we have 5 hypothesis tests. So 2 tests for 1 sample, mean compared to a hypothetical value, proportion compared to a hypothetical value, and then comparing 2 population means, comparing 2 population proportions. Right, so I want you to go through all the other questions on worksheet. Please complete the worksheet. And then I will give you some chapter exercise questions to try on your own. So it's important that you get as much practice as possible. And it's important always when you run a hypothesis test, be consistent. Write down the steps. Write down these 5 steps and then write down the complete statement of what your conclusion is actually is about. Okay.